Hi guys, today we're going to solve a sample problem in Chapter 3 of Thermodynamics and Heat Transfer, the ideal gas and the corresponding states and incompressible models. The sample problem is a zero point 0.5 cubic meter rigid tank containing hydrogen at 20 degrees Celsius and 600 kilopascals is connected by a valve to another zero point 0.5 cubic meter rigid tank that holds hydrogen at 30 degrees Celsius and 150 kilopascals. Now the valve is open and the system is allowed to reach the thermal equilibrium with the surroundings, which are at 15 degrees Celsius. Determine the final pressure in the tank. The given values are the volume in tank 1, which is equals to 0. 0.5 cubic meter, as well as the volume in tank 2. The, the temperature at tank 1 is equals to 20 degrees Celsius plus 273.15 is equals to 293.15 Kelvin. And the temperature at tank 2 is 30 degrees Celsius plus 273.15 is equals to 303.15 Kelvin. The pressure in tank 1 is equals to 600 kilopascals and the pressure in tank 2 is 150 kilopascals. By treating our hydrogen as our ideal gas, we were going to solve for the total volume and the total mass. First, we have the total volume is equals to volume of tank 1 added to volume of tank 2. We have 0. 0.5 cubic meter plus 0. 0.5 cubic meter is equals to 1.0 cubic meter. Since our tank contains the hydrogen, we were going to determine the gas constant of the hydrogen by using our property table. In table A-1, the gas constant of our hydrogen is equals to 4.124 kilopascals cubic meter per kilogram Kelvin. Using the ideal gas equation, with the mass given, we have PV is equals to MRT. Since the mass is unknown, we rearrange the equation into M is equals to PV over RT, or mass equals to our pressure multiplied to the volume over the gas constant times the temperature. Plug in the values in our tank 1, we have 600 kilopascals times 0. 0.5 cubic meter over 4.124 kilopascal cubic meter per kilogram Kelvin multiplied to 293.15 Kelvin. Crush out the same units, we have 0.248 kilogram as the mass of our hydrogen in tank 1. Next, we were going to solve also for the mass of our hydrogen at our tank 2. The same formula and plug in the values, we have 150 kilopascals as our pressure times the 0. 0.5 cubic meter over 4.124 kilopascal cubic meter per kilogram Kelvin as our gas constant times 303.15 Kelvin as our temperature, and then crush out the same units, we have 0.06 kilogram as our mass of hydrogen in tank 2. Next, we need to sum up all the mass of our hydrogen. We have 0.248 kilogram as our mass of the hydrogen in tank 1 and 0.06 kilogram in tank 2. So in total, we have 0.308 kilogram. Lastly, we were going to determine the final pressure in the tank. Since the value is open and two gases are allowed to mix while achieving thermal equilibrium with the surroundings, which are 15 degrees Celsius or 288.15 Kelvin, we were going to use the equation of our ideal gas again, which is PV is equals to MRT. Rearrange the formula, we have pressure equals to mass multiplied to gas constant times temperature over volume. Plug in the values, we have 0.308 kilogram times 4.142 kilopascal cubic meter per kilogram Kelvin multiplied to 288.15 Kelvin over 1.0 cubic meter. Crush out the same units, we have 365.84 kilopascal as our final pressure in the tank. So that's all for today, guys. I hope you've learned something and see you in our next video.